Now you know what LingSync does and you have some experience using it. In this fourth and final portion of the tutorial, I would like to show you something of what I am currently doing to improve and add to LingSync. That is, I'm going to talk about features and components that are currently under development. LingSync spreadsheet, as we have seen, is simple and easy to use. It focuses on helping field workers to collaboratively build corpora of fieldwork data. LingSync Prototype is another LingSync GUI. It has more features, including import, better export, and the ability to function offline without an internet connection, and then sync your data with the central server-side database when internet connectivity returns. The Online Linguistic Database, or OLD, is a program that I created while I was a graduate student. It is a web application for linguistic fieldwork, and it's quite similar to LingSync. It has powerful search capabilities, it has features that help groups of fieldworkers to build a consistent dataset, and it helps in the creation and export of texts and research papers using data in the system. The Morphological Parser Creator, or MPC, is a component of the OLD that allows users to create morphological parsers using data in a collaboratively created fieldwork database like the OLD or LingSync. Parsers created using the MPC can handle phonological opacity. Dative is a program that will incorporate the good parts of all of these other tools. At this point, Dative is not ready for production, but it will be soon, so I will present a brief demo of it. Dative was designed to look like a desktop application. So here we have a menu bar at the top. Right now, because we're not logged in, we have application settings, the home page that we're looking at now, and the register dialog, and then under account we can log in. You'll see keyboard shortcuts are defined, so everything is keyboard shortcuttable. You can go to application settings using a keyboard shortcut or a click here, go to application settings. And this shows our active server. So Dative was designed to be able to work with multiple different servers, OLD servers or LingSync servers, and LingSync servers are also called FieldDB servers, so you'll see that term in this demo. We can show the currently configured servers, and these are the default ones that come with Dative. And the FieldDB development one that's being served on my computer is the active one right now. Then this is the one, FieldDB at auth.lingsync.org, that you use when logging into LingSync, so I've just made that active. You can click this button to create a new server if we've set up our own OLD web service or LingSync web service, and specify the URL and the name here. But I'm just going to delete that since we don't need that, and we'll make FieldDB our active server. And then we'll go to log in. We can either go under account here, or we can click this little icon and log in. FieldDB will be selected as the active server. I'll use my credentials to log in. I'm logged in, and now you see the corpora that I have access to. And if you click on this, you can see the details of the users of that corpus, the Blackfoot corpus. Right now there are only 2 users, and here we can change that. So I can add a writer. So I will add our friend Nemo33. And then I can remove JRW Dunham Read Only as a reader. I can add another admin. I'll just leave that for now. We can expand all of these by clicking on this button. It'll just take a while to fetch all the details. And now we have them all open, and we can see the various servers that I have access to and the users. Now, if we collapse them all, we'll see that I don't have these icons in these 2. That's because I'm not an administrator in Inuktitut or test corpora, so I can't manipulate the users there. I could also add a new corpus using that interface there. And now that we have this open, we can see additional items on the menu bar, so we can go to the add interface. Shouldn't be there. And we can add new data, and this is nice because it expands to fit your content, and then you can add multiple translations with multiple compatibility values. Something like this. You can add your tags like that. Choose elicitation methods. Select the data was elicited. You get the idea. And we can, if we hover over this, it'll show us what we're logged into and with what username. Then we can log out here. Now I'm going to register with on my current FieldDB development server, and I'll just call it test LSA 2015. Silly password and a silly email just to show you how it works. And there, now I can register. Now it'll invite me to log in with that newly created user. And now I can look at that person's default practice corpus, and why not add another admin, which is myself. There we go. So now I'll show you what browsing your data looks like via the Dative interface. So here we see some of my Blackfoot data, and we can choose how many data points we see on each page. And we can jump to a nearby page, jump to the next page, or to the last page with keyboard shortcuts. Left and right arrows move things across pages, and then control left and right move to the first and last pages. We can expand all of these to see more details on them and collapse them. You can also click on them to expand them, and pressing tab will move through the data points, and we can see the more detail when we expand them, and then we can perform certain actions on them like that. So having shown you what Dative looks like, I will now very briefly review the good parts of LingSync Prototype, the OLD, and the OLD Morphological Parser Creator that I plan to incorporate into Dative. LingSync Prototype works offline, and when internet connectivity is restored, your locally stored data are synced with the server-side database. This is useful in certain fieldwork contexts where an internet connection is available sporadically or not at all. LingSync Prototype also has more comprehensive import and export functionality. This is important because it allows users to easily get their data in and out of LingSync for a variety of different purposes. For example, good import-export makes it easier for field workers to use LingSync and other tools, such as Flex, Elan, and Toolbox, in a complementary manner. The LingSync Chrome app also has a more customizable data structure. In contrast to the predefined field templates of the spreadsheet GUI just discussed previously, the Chrome app allows users to define whatever fields they want. The Chrome app also has the encryption features alluded to previously. That is, it allows for more fine-grained control over who has access to which data, which is useful in certain fieldwork contexts. The plan is for Dative to implement all of these features, but import and export are most urgent. Now I'll discuss some of the more interesting features of the Online Linguistic Database, or OLD, that will be incorporated into Dative. Here's a screenshot of the Blackfoot OLD. This is a web application that has been used for the past 6 years or so by a number of fieldworkers and researchers to collaboratively document and study Blackfoot. This screenshot shows the beginning of a representation of one of my elicitation sessions. These are some of the salient requirements that I had in mind when creating the OLD. I wanted to create data that are consistently structured and formatted. I wanted the system to make it easier to create higher-level artifacts from my data points, for example, research papers. I also wanted it to help me to get the data that I need with speed and precision. These are some of the OLD features that respond to these requirements. Morpheme cross-referencing and configurable validation promote the creation of consistent data. The general-purpose text creation feature allows for the creation of higher-level artifacts like research papers. And the search features help with speedy retrieval of precisely the data that are needed. This slide illustrates the OLD's morpheme cross-referencing feature. When you enter a morphologically complex form, the OLD displays the morphemes as color-coded links to the lexical forms that already exist in the database. This provides immediate visual feedback on the lexical consistency of an IGT morphological analysis. In short, the blue links indicate perfect matches, the green links indicate partial matches, and the absence of a link indicates that the morpheme shape or gloss matches no morpheme in the database. This slide illustrates input validation, another consistency supporting feature of the OLD. Users can specify inventories of symbols that can be used to constrain the types of inputs that are permitted in particular fields. This can help to ensure that the orthographic, phonetic, and/or phonemic transcriptions have a base level of consistency. A related feature is orthography conversion. A user can choose an interaction orthography. The OLD will transparently convert inputs to and outputs from a designated storage orthography for consistent storage in the database. This is useful for endangered languages fieldwork contexts where it is not uncommon for multiple orthographic conventions to coexist. The OLD allows for the creation of texts. An OLD text is an ordered list of references to forms in the database. The text can then be exported as a LaTeX document, which can then be used to generate a PDF. The Blackfoot datasets that we just used for the hands-on portion of the tutorial were created via the OLD in this way. An OLD text can also contain prose and markup for formatting and example cross-referencing. Texts can themselves be associated to any number of audio, video, or image files. The OLD has powerful search functionality. An OLD search is an arbitrarily complex tree structure with Boolean operators as the non-terminal nodes and filter expressions as the terminals. The search expression at the top of this slide requests all forms that are sentences and are not ungrammatical and either contain the morpheme shape wa or contain approximate like gloss. As indicated here, OLD searches can make use of regular expressions. Dative will include a user-friendly GUI for creating these types of searches. The OLD has an interesting feature that allows users to search for forms that contain specific morphemes, even when homophony and synonymy would otherwise complicate this task. Imagine that we want to retrieve all forms that just contain morpheme 1, but our database also contains morphemes 2 and 3. Morpheme 2 has the same shape as morpheme 1, and morpheme 3 has the same gloss as morpheme 1. Notice the shape gloss category field on the bottom rows of all of these tables. This is automatically generated by the OLD by serializing the values of the fields in the first 3 rows. The shape gloss category is essentially a unique signature for each morpheme. If we use a regular expression to match the shape wa in the morpheme shape field, we will get forms that contain either morpheme 1 or morpheme 2. But what we want is just forms containing morpheme 1. If we try to improve this by matching wa in the morpheme shape field and prox in the gloss field, then we will get all forms that contain morpheme 1, which is what we want, but we will also get any forms that contain both morpheme 2 and morpheme 3, which again is not what we want. The solution is to search for wa followed by prox in the shape gloss category field. Only this search will give us all and only the forms that contain morpheme 1. The OLD also allows for structural searches using tgrep2. That is, it allows you to search for phrase structure patterns. While this is particularly useful for linguists interested in syntactic phenomena, it does require that phrase structure representations already be present in the database. Now I will give a brief, high-level overview of the morphological parser creator. There are 2 big features that I want to see in a fieldwork application. I want to be able to automate the task of creating morphological analyses, and I want the system to help me in evaluating my analyses. This is what I mean by automating the parsing task. I want to type in my transcription and have the system automatically generate the morphological analysis in interlinear gloss text format. While manual parsing is useful practice when developing proficiency with a new language, this task soon becomes a tedious time sucker. However, morphological parsers contain useful information, particularly for search, as we have just seen. On the other hand, if I do manually enter a morphological analysis, I want the system to tell me if it is incompatible with models I have specified. More generally, I want a tool that can identify all data points that are incompatible with certain models. Obviously, this would be useful for linguistic analysis. The morphological parser creator is a function that takes as input an ordered set of phonological rewrite rules in 3 corpora and returns as output a morphological parser. The fact that the parser creator is incorporated into collaborative fieldwork software such as LingSync makes it easier to build and assemble the required corpora. And the parser creator itself helps with writing the phonological rewrite rules by automating the task of evaluating phonologies against specified test sets. This schematic shows the architecture of the morphological parsers created by the parser creator. The morphophonology component returns a set of possible morphological analyses. Because natural language is full of ambiguity, a single service transcription may correspond to multiple morphological analyses. The candidate ranker, represented by the green box, transforms the unordered set of candidates into a list of candidates ordered according to their probability given a corpus of expertly analyzed words. In terms of implementation, the morphophonology is a finite state transducer, while the ranker is an n-gram language model. In terms of their specification, the lexicon, morphotactics, and ranker are all automatically extracted from corpora that a user creates and specifies for these purposes. The phonology, however, must be specified by the user as ordered phonological rules. But the good news is that as linguists we already know how to do this. Clever computational linguists and developers have already created tools to convert our ordered phonological rules into computer programs that efficiently translate surface representations to underlying ones and back again. To test the parser creator, I created several morphological parsers for Blackfoot, using data from published sources and the Blackfoot OLD to build the corpora, and using the phonological analysis of Donald France's grammar as the starting point for composing the phonology. I evaluated the parser against the morphologically analyzed words of the Blackfoot OLD. The parser creator helps in the creation of a phonology by allowing you to write tests that the phonology should pass, and then automating the task of determining how many tests pass and which ones fail. This slide shows some tests in one of my Blackfoot phonology scripts. The morphological parser creator runs the tests against the phonology and reports which ones fail. This way you can tweak the phonology until you get an optimal success rate. Since a phonology is a computer program, my Blackfoot phonologies are all open source scripts that are version controlled and available on GitHub. The best performing Blackfoot morphological parser that I created gets exactly a correct parse 17% of the time. Bear in mind that this is on quite an inconsistent dataset. It has an F-score of 0.4. Its morphophonology returns the correct parse 60% of the time, and its candidate ranker is only 28% successful. The failures of the morphophonology systematically reveal gaps in the standard phonological and morphological analyses of Blackfoot. Once those gaps are filled, which will involve integrating existing theoretical linguistic analyses and perhaps improving upon them, the parser's performance will in turn improve. And the ranker's performance will improve once we have more expertly parsed data to train the models on. And we'll get more data to feed to the ranker by intelligently integrating these imperfect parsers into the data entry interfaces of GUIs like LingSync Dative. A major next step in the development of LingSync will involve adding to Dative interfaces for creating morphological parsers. These interfaces will use the existing morphological parser creator web service of the OLD. When the data entry interface of Dative will then be configured to use these parsers to intelligently suggest parsers ranked according to probability. Then these tools can be used by fieldworker linguists to expedite workflows and evaluate models. So, I have shown you the why and the what of LingSync. And now I have shown you how it will be improved in the immediate future by incorporating components that have already been built by myself and the other LingSync developers, these being better import and export functionality, features for creating exportable general-purpose texts, including data points in the databases, using data points in the databases, powerful search functionality, a morphological parser creator and integrated morphological parsers to expedite data entry and automate the testing of analyses, and finally, a better GUI. If you are interested in contributing to LingSync and/or LingSync Dative, I encourage you to do so. Please talk to me if you're interested in this. If you didn't already know, creating software that runs in a web browser has become a lot more pleasant in recent years. I'm developing Dative using a programming language called CoffeeScript, which basically makes JavaScript more Python and Ruby-esque, that is, arguably easier to read and write. Also, there are now a number of nice testing frameworks for JavaScript/CoffeeScript applications, and task runners that make it easier to compile, test, build, and deploy your application. Finally, Chrome's and Firefox's developer tools make the task of debugging much easier. Here's a screenshot of some of Dative's CoffeeScript source code on GitHub. And this is the URL to visit if you want to contribute to it, or just see what's under the hood. Again, if you're interested in contributing, or if you have a student who might be, or if you have a project or tool that you think might be usefully incorporated into LingSync and/or LingSync Dative, then please do let me know. Thank you for listening to me talk and for participating in the tutorial. I'll now do my best to answer any questions you may have.